Looking at a piecewise function, we want to see how we analyze this piecewise function. And really the key point is going to be the point at which it's going to go from one function to the other. Okay, so that's going to be something that we need to look at. In fact, the first thing we're going to do is check for continuity. And to do that, what I'm going to do is see if the value for f is the same from the left by plugging in x equals 2, and then seeing if into the green function, and then plugging in x equals 2 into that red function, and see if they match, and that will give us the continuity. So I'm going to show this more formally with a limit. So the limit as we go from the left-hand side to positive 2, we're going to plug it into the top function, so we get 2 squared plus 2 is 6 plus 1. That's going to give us a y value of 7 from the left-hand side. And then from the right-hand side, we're going to use that red function. So as we approach 2 from the right-hand side, we're going to use the second function there. So we get 11 minus 2 times 2. That's 11 minus 4. So we get a y value of 7. And the fact that it is actually defined at 2 and 7 from that green function. So I'm going to draw 2 and 7. Okay, not only is the limit the same, it's also defined at that point. What that indicates then is that this is continuous at x equals 2. Okay, so that's important. We need to establish continuity first. Okay, secondly, we want to check for any critical points. Okay, so actually let's do the zeros first. I'm going to check for zeros. For x is bigger than 2, x is bigger than 2, we're going to look at the red function. And solving that red function for x is bigger than 2, we get x is equal to 5.5. So it's going to hit the x-axis at 5.5, right about there. Okay, so oops. Let's move that over a little bit. And at 5.5, we're going to have a 0 here from the red graph. And if we take a look at the green graph there, we're going to see if it's going to have any zeros. So solving that quadratic equation, we get x is equal to -1 plus minus the square root of 1 minus 4 times a times c. Okay, and I end up with a negative discriminant. So that means that -1 plus minus square root of -3, that means there's no solution. So no zeros. Okay, so that's my only zero. So now I want to see for min and max points. So I'm going to find my derivative. So I'm going to calculate my derivative, f prime. And I need to have my f prime defined for the two different domains. Okay, so my f prime of x is equal to, so I have my domain of x is less than or equal to 2. I'm going to differentiate that function to 2x plus 1. So there's my derivative for that green part. And the derivative for the red part there is going to be a slope of -2. And that's going to be for x's that are greater than 2. Okay, so I don't have any zeros for the red part. In fact, it is just a linear function, so we know that it's just going to be a straight line through there. But we do have zeros for the quadratic part. So in fact, our zero is going to be at -1/2. So at -1/2, we have a zero slope. So we should test the derivative on both sides. So f prime at -1, that's going to give us, at -1, we're going to get negative slope. So on this side, it's going down to the 0. Okay, we have a horizontal tangent. And then at f prime at 0, that's still going to be on the green side. It's going to be equal to positive. So we end up with a positive slope on this side. So our slope chart is going to look like that. And we have a point of that we have to be careful of, is that at the transition point, we need to know what's going on there. So to see what's going on at the transition point, we're going to have to check the slopes of the transition point. Okay, so we can see that the slopes are actually different. So we know there's going to end up being a kink. But to show this more formally, we're going to do this. The limit as x approaches the transition point of 2 from the negative side, I want the derivative value. Actually, I'm going to write it in as f prime of x. I want the limit of the derivative as it comes from the left, and I know that that's going to equal a slope of positive 3. And then from the right-hand side, we're going to do a limit for the slope as well. The limit as the slope goes to 2 from the positive side of f prime of x, using the red function, we know the slope is negative 2. So what we know about this then is that there is a kink in the graph. So putting this together, this means that there is a kink. The slopes do not match, therefore there's a kink in the graph at 2. And in fact, we have to then state that at x equals 2, the slope is undefined. Okay, so then that means that we have another point that we have to check. So we have to now check the slope on the other side of 2. So I'm going to do an f prime check on the other side of 2, which means I'm going to use a red function. So f prime at x equals 3, using the red graph, is going to be negative 2. Well, that's going to be negative slope. So it's going to be a negative slope down there like that. And again, we can see from our graph, we already know what that function is. It's a slope, the function is y equals negative 2x plus 11. Okay, so we already know that's a negative slope graph there. So there's our parts here. I'm just going to put it in. I want to draw my parabola in, so I really should have a vertex. So I'm going to draw my table of values here. I have my kink point, which is at positive 2 and positive 7. I've got a 0 at 5.5 and 0. And I want a vertex for this parabola, so I'm just going to use Vieta's formula. So the p-value of my vertex is going to be negative b over 2a, so it's going to be at negative 1/2. Okay, and that means that the y value, when I plug negative 1/2 in there, I'm going to get 1/4 minus 1/2 plus 1. So it's going to be 1 1/4 minus 1/2, which is 3 over 4. Okay, so at negative 1/2 and positive 3 over 4, I have my vertex. Okay, so I'm just going to draw my symmetrical point to that other point there. So I'm going to draw that in green. So this is going to be at, looks like it's going to be, the other side of that point is going to be at negative 3, positive 7. So that's going to be my point right there. And then I can sketch in my parabola. It's going to look like this, all the way to my vertex and up, and then I have to stop at that point. And I can see that I have a kink in the graph, and it's not a point of discontinuity, but the derivative is undefined there because the slope from one side is different than the other. And again, when I see that the left-sided slope and the right-sided slope is different, I end up with what we call a kink in the graph.